Way to go, Mosh. And we have a nice video in here as well about this. Maybe
Yeah,
we
so
can
this
have a
video
look
is
at it. Yeah.
this video is going to explain a little bit. So, why this happens. So, a horseshoe appears black at room temperature, right? There's no heat on it. It absorbs all the colors, but when you start heating it, they emit radiation. They emit energy. So when you heat something and you touch it, you feel it, right? Well, if you touch the red part, well, I wouldn't recommend it. But if you did, if you touch the red part, it's going to be pretty hot. But if you touch the white part, it's going to be even hotter, right? You wouldn't want to do that. Look at that. It's about 4,000 degrees Kelvin at the hottest part, the blue part. You were just saying it's ordered from hot to, the most energy to the least energy, right? Well, you can see it here, even when you heat something. You see the varying degrees of heat in the horseshoe. So this and it right there, you see it again. You see like a spectrum within the metal of frequencies of heat and radiation. I think, Jihan, doesn't this explain a little bit about the properties of iron? Like, maybe like if we heated something else, they'd be different colors. Why do you think iron is this color?
I'm not sure about that. Like, I think they have some kind of physical properties, right? But I think Baha can explain maybe better to us because I know he's into these kind of stuff. So let's go, Baha.
So what's actually really interesting is uh, the iron, when you heat it, it actually emits every single color in the spectrum. It just has a peak at the point, and the sort of color that we see is actually the peak. Even when we see the iron as being red, it actually produces a tiny amount of blue light that we cannot see because of the red light, because the temperature that it's at sort of forces it to produce light at a certain point. And the sort of spectrum that we looked at, the visible part of the electromagnetic spectrum, is actually a small part of the whole spectrum. There is a lot of different areas of the spectrum that we cannot see with our eyes. And once we actually pass a certain threshold, that the iron starts producing these lights, emitting these lights that we can actually see ourselves. And that's the point where the red color sort of starts.
Pretty good. Like, why is iron in that color? I mean, why? Because as it is heated, it starts to like emits higher frequencies more, and then we see blue. Omash, do you know, like, are there any like different colored stars? Do you know what color is the stars? Are the stars? Do you know?
I don't actually know because I'm not an astronaut.
But let's think together, okay? Let's think together. So what do stars do? I mean, they burn, right? They burn.
Obviously white.
Yeah, there are white. Okay, what else? There might be. Like if the temperature, huh?
Yellow.
Yellow. Okay,
Yellow.
and what else?
Do you think there's blue stars so much? Do you think there's such a thing as blue stars?
I don't think so.
You don't think so? What do you think, Baha?
Well, there actually are blue stars, and they are the hottest of the stars out there. And the colder ones are the red stars. The hottest ones are the blue stars. And the reason why, even, for example, if we look at our sun actually produces, blue and red, because, during the middle of the day, the sky is blue. That's the blue light coming from the sun. And during the dawn or the dusk parts, the sky is red because the sun also produces red color, which is why I talked about how each of these stars actually produced every color possible. It's just that the most amount of color that's emitted by the star changes depending on what temperature it's at.
Mm-hmm.
So the blue ones are the hottest ones, and the red ones are the smallest ones. Intact, there are these stars called red dwarfs. Those are very small, and they're usually in the earlier phases of their development, so they keep growing, and they are red because they're quite small and they don't produce that much energy. They're not as hot as some of the other stars out there.
So if I was thinking about the electromagnetic spectrum, I would say that they would have low frequency and lower energy. Is that correct, Baha?
Yes, and
okay.
Another way of saying that they have low frequency is to say that they have a high wavelength, because those are inversely proportional to each other.
Okay, so if I'm understanding this correct, and Omanch, help me out. If something has low frequency, so it's like a red color, the wavelength is going to be closer together, like a higher one? Or is it going to be more drawn out, like a lower, like longer wavelength? What do you think, Omanch? I'm not sure. I might need some help.
I think so. When you talked about the smaller to bigger one, that's actually in the volume radius. When we place something, it's in the volume radius. When we put it in 0, it's in the smaller frequency. And we put it at 100, it's the bigger frequency. So I think so. It's the same with temperature, but with the different order.
Perfect. I think you explained it very well. So for our listeners out there, Omanch explained how frequency of a wavelength and color are very, they kind of come together. So like if something's blue, you've got a high frequency and it's hotter, it emits something hotter. But if it's red, lower frequency, the wavelength is going to be a bit bigger, a bit longer, and it's going to be what? A little bit lower energy, a little bit less hot. So what color do you think our sun might be? I think on a hot day, I feel pretty hot. I get like sunburns. It's pretty hot. So what color do you think our sun is? We can't look at it, but just guessing. I think Jihan is giving some tips for us.
Maybe maybe some clues. Like sometimes I see our sun red when especially it is like rising or during the sunset, right? And sometimes I see our sun as yellow, but if you go like towards the sky, if you go out atmosphere, the color of our sun is the color of our sun approaches to white, like it is whitish, yellowish kind of thing. So it is in the middle. So we can say that's what I know. I might be wrong, but that's what I know. So
yeah, we're not astronauts.
Yeah, we are not astronauts.
We know a lot about science.
Definitely. So I think we are ready to move to the next question.
Definitely. So we're gonna move on to a new video. This is gonna maybe come from like left field. We're gonna see what exactly is going on. It's a little bit different from the sun, but we're seeing this guy put like these black, what are these? Like a hose, a tube in something. Have you seen this before, Omanch?
No.
No, neither have I, so I think we're going to learn together. Maybe Jihan and Bahano. But this guy, so what's something you can observe? Like what colors is he using? I'm only seeing black, right? Yeah. Why do you think he might be using black and not, let's say, white or like blue or, I don't know. My favorite color is green.
I love green as well.
Yeah. So why is he using black, do you think?
I think we will need to figure out after the question, maybe.
Exactly. So I think let's figure out what this is, but we have once we figure out what it is, we'll explain why it's black. So let's go to let's figure out what this is. Jihan, can you help explain what this what this guy is doing, what device this is?
Yeah, so like this is kind of a solar heater. I worked in solar energy sector, so I was building these kind of things. So we were using sun to heat the water. Okay. Do you have solar heaters, Omaj? Have you ever seen solar heaters on top of the roofs? So they
I've
are
seen solar panels, but not solar heaters.
okay. So solar panels work the same way actually. Solar panels, photovoltaic panels, they emit, they actually work with the sunlight. So sunlight hits on those panels and they produce electricity. We can maybe look up to that solar panels in different show, but in here this is solar heaters. So when you go up to the sun and when you are sunbathing, like you start heating, right? Your body gets hotter and hotter, right? So it works the same way. So these tubes are used for water, like water circulates inside of these tubes and sun heats this water and we can use it while taking shower. It's pretty nice. We get use of the sun.
Yeah, I like hot water when I take a shower. There's no cold water that I can take showers in. So this heats up something, right? It kind of reminds me of like when I'm wearing a black shirt versus a white shirt on a hot day. You know, which one would you get hotter in if you were outside? A black shirt or a white shirt?
What do you
Omaj,
think,
you know?
Omaj?
I think the white one because of the cloth type.
That's an interesting question. I mean, answer. Like, so what the cloth is made out really makes a difference whether you're hot or not, right? Yeah. Well, also, did you know that color makes a difference whether you feel hot or not?
It's back to the previous video.
Yeah, it's a little bit about color. We're kind of going full circle here. We're going back to the idea that color and heat are kind of like one-on-one, right? So maybe if we go to the next question, we'll see what everyone in the app thinks about this, why it's black, and then we can answer and figure out why certain colors affect how hot you feel. How about that? Sound good?
Maybe because of the temperature.
Yeah, that's a really good start. So why don't we ask the question and see if you get the answer right, and then we'll explain. Okay, so I'm going to read the question. Are we ready? All right. So why are solar heaters on rooftops painted in black? A, they look nice. B, they can absorb all the sunlight. C, they smell nice. Or D, they taste nice.
So there are lots of information about the taste, look, smell of black paint, but I've never experienced that.
Yeah, I might have put like something in my mouth when I was like 3 years old to taste it, but I'm not sure what those tubes taste like. I don't think it's that. No? Yeah, that'd be weird. Tubes might smell nice, but I don't know. They're made out of what? Rubber, plastic? What kind of material might they be made out of?
I think tubes, I know this, but we can maybe think on this. Tubes are made of mostly copper.
Copper.
So, yeah.
Also metal.
Yeah, it is also metal, but it is a different metal. It conducts heat and electricity pretty good actually. It's a conductor.
Wow.
Yeah, it has a conductivity. I mean, you can heat copper pretty fast, and also it's the resistance to conduct electricity is very low for copper. So that's why copper is being used for electric cables as well. But in here we use it because of its heat conductivity properties.
So it can take a lot of heat, and it can travel, like heat can travel in copper really well. Like from one end, if you heat copper on the other end, you'll feel it on another end of the rod, right? So
Yeah, definitely.
we're talking about heat, we're talking about the color, and we're talking about having to keep something hot, right? So if a solar heater needs to stay hot, I wonder, they make it all black because it either reflects all the sunlight or it absorbs all the sunlight.
What do you think, Omash?
I think the same.
Yeah, it absorbs.
It absorbs all the sunlight. So going back to my observation, when you wear a white shirt versus a black shirt, the white shirt actually reflects all the sunlight, but a black shirt absorbs it, so you feel extra hot in a black shirt. You know, black has what? All the colors in it, I think? Baha, do you think black has all the colors in it?
Well, when you are painting something black, you actually end up using every single color of paint possible. You combine them and you create black and you dye it that way. So, yes, technically it does.
Very good. And I think Jihan